Hello everyone, I am Shalini Kambli, Sri Siddheshwara Government First Grade College, Nargund, BSc First Sem PCM. Presentation topic is titration, definition, DOMS, theory of acid base indicators. Content, definitions, standard solution, titration, equivalence, back titration, endpoint, and indicators. And definitions, standard solution, a reagent of a known concentration which used in the titrometric analysis. Titration, the process of adding a standard solution from burette or other liquid dispensing device to an analyte in the form of solution. The reaction is believed to be completed. Equivalence point, the point in the titration process when the amount of titrant is chemically equivalent to the amount of analyte in a sample. And back titration, the process of adding excess amount of standard titrant, and the excess is determined by back titration using second standard. The equivalence point corresponds to the amount of initial titrant is chemically equivalent to the amount of analyte plus the amount of back titrant. Endpoint, physical change occurs which related to the chemical equivalence. Indicators, indicators are used to give an observable physical change endpoint or at near the equivalence point by adding them to the analyte. The difference between endpoint and equivalence point should be very small, and this difference is referred to as titration error. Acid-base titration definition. An acid-base titration is quantitative analysis method used to determine the concentration of an unknown acid or base by neutralizing it with a base or acid of known concentration. It is based on neutralization. Acid plus base gives to salt plus water. Principle is the process of depends on the reaction between hydrogen ions H plus from the acid and hydroxide ions OH plus ions from the base to form water. At equivalence point, the amount of acid equals to amount of base, that is N1V1 equals to N2V2. Indicators used: phenolphthalein, methyl orange, litmus. Types of acid base titration. First one is strong acid versus strong base. Example is HCl versus NaOH. Second one, strong acid versus weak base. Example, HCl versus NH4OH. Third one is weak acid versus weak base. Example, CH3COOH versus NaOH. Fourth one is weak acid versus weak base. CH3COOH versus NH4OH. And first one is strong acid versus strong base. Strong acid versus strong base. Example, HCl versus NaOH. Process, HCl plus NaOH gives to NaCl plus H2O. Both acid and base are completely ionized. At the equivalence point, the solution is neutral. Indicator, phenolphthalein. Phenolphthalein is colorless to pink or methyl orange, red to yellow. And second one is strong acid versus weak base. Example, HCl versus NH4OH. Process, HCl plus NH4OH gives to NH4Cl plus H2O. Weak base partially ionizes. At the equivalence point, solution contains NH4 ions, making it acidic. Indicator, methyl orange since pH. Weak acid versus strong base. CH3COOH plus NaOH gives to CH3COONA plus H2O. Process, weak acid partially ionizes salt from hydrolysis, making the solution basic. Indicator, phenolphthalein. Fourth one, weak acid versus weak base. CH3COOH plus NH4OH gives CH3COONH4 plus H2O. Example is CH3COOH versus NH4OH. Process, both acid and base weakly ionized. pH changes gradually, no sharp changes near equivalence point. Equivalence point near pH and but cannot be detected by ordinary indicator. No suitable indicator use pH meter or conductometer titration. And acid base indicator or pH indicator. The indicator used in acid base titration which changes the color with pH of the solution is called acid base or pH indicator or H ion indicator. It helps to determine whether a solution is acidic or basic. Example, phenolphthalein, methyl orange. Working principle, indicators are weak acids or weak base that exist in two different colored form, one in acidic medium and another one is basic medium. The color changes occurs due to a shift in equilibrium depending on the H ion concentration. and table is indicator. Phenolphthalein. Phenolphthalein pH range is 8 to 9.8. Phenolphthalein acidic color is colorless. Phenolphthalein basic color is pink. Second one indicator is methyl orange. Methyl orange pH range is 3.1 to 4.5. Methyl orange acidic color is red. Methyl orange basic color is yellow. Litmus. Litmus acidic color is red. Litmus basic color is blue. And fourth one is methyl red. Methyl red pH range is 4.2 to 6.3. Methyl red acidic color is red. Methyl red basic color is yellow. And selection of indicator. The indicator should be chosen such that its pH range falls within the equivalence point of the titration. Types of titration. First one, strong acid versus strong base. Suitable indicator is phenolphthalein. Second one, strong acid versus weak base. Suitable indicator is methyl orange. Third one, weak acid versus strong base. Suitable indicator is phenolphthalein. Weak acid versus weak base. Suitable indicator is no indicator. Use pH meter. Ostwald theory of acid-base indicator. Acid-base indicator is either a weak organic acid or a base, so it dissociates slightly in the solution. The colorless to the undissociate molecules is different form of the color form of the ions formed. H ion gives H plus ion minus. H ion is color A. Ion minus is color B. That is equation 1. Equilibrium constant, indicator constant. KINA equals ion minus H plus divided by H ion, equation 2. The ratio of the product of ionic concentration of constituent ion of the indicator to the concentration of unionized form. Since the species ion minus and H ion have different colorless, the actual color shown by the indicator will depend upon the hydrogen ion concentration of the solution. If the solution is acidic, high concentration of H plus ions shifts equilibrium to the left, so unionized form H ion predominates to color 1 appear. If the solution is basic one, OH minus ions combine with H plus concentration, the equilibrium shifts to the right. Action of phenolphthalein. It is a weak acid. It changes color depending on whether the solution is acidic or basic. Chemical representation. HPS gives H plus pH minus. HPH unionized form is colorless. pH minus is ionized form to pink in acidic solution. The concentration of H plus ions is high, so equilibrium shifts to the left and the unionized form HPH predominates. In basic solution, OH minus ions combine with H plus to form water, reducing H plus ion concentration. The equilibrium shifts to the right, forming more pH ions. Solution turn pink. Reference: the BSc First Sem textbook by Vinayak M. Nayak. Thank you.